negative 2, x minus 4 squared, and x squared minus 25. Now, I would like to directly fill out the table and not have to write down every step, but it's up to you if you want to. Okay, domain, please. Very good, it's polynomial. Okay, let's write here the degree. Be very careful. What is the degree of this? You're right, the whole thing. But what is the degree of this for everyone to see? 2. What is the degree of this? 2. So if this is x squared and this is x squared, what will be the degree at the end? Yes, degree 4. What is the maximum possible number of turns? I'm not saying it has to have that, but what it cannot have more than 3? 4 minus 1 is 3, is max possible number of turns. It cannot have more than 3 max or min, or a combo. Very good. Next step. The x-intercepts. How do we determine the x-intercepts? Awesome. So then I have negative 2, x minus 4 squared, x squared minus 25 equals 0. Yes, or divide, actually. We divide both sides by negative 2. We don't care about that number. So x minus 4 squared. Let's factor out x squared minus 25. How do I do that? X minus 5. Very good. How many solutions will you give? Exactly, 4 solutions, because the degree is 4. So please give 4 solutions. X equals negative 5, x equals 5. X equals 4, multiplicity, 2, multiplicity for negative 5, multiplicity for 5. So what type of cross, turn, whatever will this be? Cross. What will this be? Very good, regular cross. What will this be? That's it. Even multiplicity, number 2, multiplicity 2 will be a turn. What if it were multiplicity 4? What would you have said? You would still have said a turn, but a slow one. Exactly. Very good. So I'm going to put them in the table. So negative 5, 0. Then 0 has to be in the table. And then 4 and 5. 4, 0, 5, 0. I have to make myself the notes on the table. So this is a cross, this is a cross, and this is a turn. The more you summarize the information, the easier it will be to graph. Very good. So now we have to find what? What is this? The y? No, we're not there yet. We haven't graphed it yet. The y-intercept. So let's find the y-intercept. How do we find the y-intercept? Good. So let's do this together. How much is 0 minus 4? A negative 4, but negative 4 squared will be 16. So f of 0 first is negative 2 times 16. How much is 0 minus 25? Negative 25. So this is 50 times 16. So how much is 50 times 16? 800? Wow. Okay, it is what it is. Very good. Now the end behavior. So let's talk about the end behavior. What is the degree then again? So any even degree must behave like the quadratic function. Either this, if the leading coefficient is awesome, or this, if the leading coefficient is very good. Let's go and see the leading coefficient. So x squared times negative 2. What would be the leading coefficient? Negative 2. So x squared times x squared will be x to the 4th times negative 2. It needs to be distributed to all terms, right? So the leading coefficient is -2. So the end behavior, because it's degree even, will it be this end behavior or this end behavior? Second one. Very good. Awesome. That's all I need. So let me put it in writing for everyone because we haven't discussed this. So this is -infinity to -infinity, and this is infinity to infinity. This one is for a leading coefficient that is negative, and this one is for a leading coefficient that is positive. This is just an indication of the end behavior, nothing else. We are done, but we have to check one more thing, which is symmetry. So symmetry f of -x, since the function crosses at these two and turns here, this function cannot be symmetric. So I'm happy if you see that and you write f of -x does not equal f of x, and f of -x does not equal -f of x, and conclude not symmetric. I'm fine. But be very careful not to write this if the function is symmetric. Okay, we're ready to graph. Let's make sense of the information that we have, and everything is in the chart. I don't care for anything else but this little chart. Ready? So the function is coming from -infinity, and it's crossing at -5, 0. 1, 2, 3, 4, 5. It's coming from -infinity and crossing normally at -5, 0. Then 0, 800, I don't know, 1, 2, so 2, 4, 6, 8. I'm going to say this is 800. So what are the options here? Let me just emphasize the fact that polynomial functions are continuous, smooth functions. If you have to twist your wrist to graph, that's probably not the right way. So they have to look like this. Very simple, smooth, continuous functions. So I don't know if this really turns here or goes further up. I don't know that. But I know that at 1, 2, 3, 4, the function has to come back and turn again. And at 5, it has to come up and cross. So it's unlikely that it's going to turn here. I don't know. That part we have to. But I show my professor that I'm thinking that this is a possibility. I'm also thinking that this is a possibility. And a little height here between these two because it's coming back to cross. But it's also possible that it will do this, but a little unlikely, I think. And we can adjust the graph later. So this is f of x, -2, x minus 4 squared, x squared minus 25. Oof, I think, okay, no, it's fine.
So how are we just assuming?
We're not assuming. We're saying there are 3 possibilities for this point to be the y-intercept, right? So here's one option. One option is that it does this and it turns before crossing the y-axis. The second option is that it turns on the y-axis, unlikely. And the third option is that it goes through the point, turns to the right-hand side of the y-axis and comes back. So this is the third possibility. We will adjust the graph in a minute after we look at the graphing calculator. But I would not erase or delete on the test any of this. I would say these are my assumptions. It can turn here, it can turn here or here. It's unlikely that it will turn, in my opinion, on the y-axis. This is possible, but I think this is more possible than this because it was kind of difficult for me to graph it on this side. However, I have 100, 2, 3, 2, 4, 6, 800 here, and I have 5 here, 4 here, and 5 here. So maybe it's possible. So these are all 3 possibilities. So now we're ready to take a look. So let's go to the graphing calculator, delete everything you have in there, and put in parentheses, -2, and then parentheses, x minus 4 squared. And then also parentheses, x squared minus 25. Okay, now I have to think a little bit about the viewing window. I already have graphed. I know I'm not going to see anything if I don't enlarge the upper part enough to cover 800, and maybe way beyond 800. I don't really care too much of the negative side. There is no action here. And I would say maybe negative 10, 10 is good enough. But definitely the height has to be much higher than 800. Okay, so let's take a look. So with the viewing window, okay, x minimum, I'm going to put negative 10. X maximum, I'm going to put 10. With a scale of 1, it's fine. Negative 5 is way too much, but let's say negative 5 is fine. But Y maximum, 800 is too small. I'm going to put 2,000 and see what happens. With a scale of 100, and maybe on a scale of 200. Okay, let's see what happens. Here it comes. It's coming from the negative side. So let me also show a little bit more of the y-axis. I want to show a little bit more of the y-axis, under the y-axis. So Y minimum, I'm going to put negative 50. Let's see. If no, it's probably not going to show negative 200. Okay, so here it comes. It crosses at negative 5 as expected because it's a smooth continuous function. It turns somewhere. It crosses at 0, 800. This is a hoax, of course. It's an error, not an error, but we know exactly that that's not the case. There's no function that goes on the x-axis like that. We know what's happening here in a minute. We will zoom in. So it turns at 4, 0. It has to come to a maximum, and it comes down and crosses at 5. So let's find that maximum first, and then investigate between 4 and 5. So second in calc, between negative 5. Oh, I'm sorry. I made an error. Sorry. So second in calc, I want the maximum, which is 4, between negative 5 and 0. I don't want to guess. Just give me the maximum. So the maximum is at negative 2.7, 1590. So I'm putting this in the chart. So negative 2.7, and it's 1590. Then I want to investigate what happens between 5 and 6. I'm going to change the Y scale to enlarge this area. So I go back to the viewing window. And what do I want for Y minimum? I want negative 5, and for Y maximum, I want 8, and with a scale of 1. So I'm going to see exactly what's happening here. I don't care about the rest. The rest is very clear now. So between 4 and 5, here it is. It turns at 4, it crosses at 5, and there is a little blip here, right? So between 4 and 5, I go back to second and calc. I want a maximum again between 4 and 5. 4, enter, 5, enter, and I don't want to guess. Just give me the maximum. So when x is 4.7, the maximum is 2.9. So 4.7, 2.9. I will not delete anything from what I presented here on a test. I will just say this is the graph. All this was my work before I looked at the calculator. Yes, please.
Now on the test,
yes.
Would you mark it wrong if we were to like choose option 2, what the graph would look like? Or
if you choose what?
If we were to choose a different option than option
No, but after you look at it, no, it's perfect. That's what I was saying. We investigated all possibilities. And then we came back and we said, but I will not erase all this work. This is legitimate work. It just shows that I know that the graph can turn on the y-axis, can turn before the y-axis, or can turn after the y-axis. But I was not expecting this only because it was difficult for me to graph it. So see, I need to do this and then twist my wrist and come. No, they have to be smooth, continuous functions. So that was more likely. But you don't have the experience I do. So showing your work is perfect. So now please choose, we still have time, please choose any type of polynomial that you would like to work on. You want an odd degree? Yes.
You know, we said we didn't need graphing calculators,
You can use mine just for the max min.
but how we all will use yours for the test?
You can use the most people have one, so you can use mine. If not, I have the software. You can put it in.
Okay.
No problem whatsoever. Yes.
So it says use those to look at, or we just use a graphic calculator to get that.
If you use the graphing calculator, make sure that you present all your work. If you don't present all your work and you just copy something from the graphing calculator, you can't get credit.
But isn't that still a good answer?
No, because you still have to show your work. You have to show the maximum number of turns. You have to show your X and Y intercepts. You will not be able to copy it. And the function may look like this, like before, and you're going to graph, and you're going to, I will know when you copy, when somebody copies from the graphing calculator without any work. Remember what we graphed a minute ago? And it showed like it was on the x-axis, but we knew it wasn't. We knew it has to have a turn and come back and cross. Okay, so let's take a look. Would you prefer an even degree or an odd degree? You choose. Odd degree, very good. Okay, so for odd degree, would you prefer a fifth degree this time? We did the third degree. Can we choose the fifth degree now?
Third,
Yes?
Third.
Third degree still? Or the fifth?
Fifth.
Okay. So let's look at fifth.
He said they're like,
I'm trying to find a fifth degree. Fifth degree. Let's make one up. I don't want to waste your time. So here it is. Okay. So let's start. What is the domain of this function? Chris, please. Abby, Ali. Yes. Thank you. Perfect. Degree, please. Very good. How do I know? This is degree what? Yes, this is degree what? Very good. So 3 plus 2 is 5. Maximum number, possible number of turns? 4. Very good. Awesome. So then let's find the x-intercepts. We said f of x equal to 0. How many solutions? I gave up. Yeah, I gave up trying to find one. So then we have 2, x minus 1 cubed, x plus 2 squared, and please give me 5 solutions. X equals 1. How many times? Very good. So what is the multiplicity of 1?
3.
Very good. And then? X equals negative 2. What is multiplicity? Very good. So we have 0. We have 1 comma 0. What type of cross or turn will this be? It's a cross. What type? Very good. Slow cross. Perfect. And then at negative 2 comma 0, what will it be? Very good. Awesome. And now let's think about the end behavior. Since the degree is right, will it behave like the linear function, one option, second option, or like the quadratic function, one option, second option? Linear. Is it this? Yes, it is, because the leading coefficient is positive. So from negative infinity to awesome. So let's determine the x-intercept. 0 minus 1. Good. 2 times negative 1 is negative 1. 0 plus 2. 2 squared. So 4 times negative 2. I have 6:15. I can finish it, or I can leave it for some next time. If you need to leave, That's fine. If you want to stay and finish it, we can stay and finish it and do it again next time. So do I continue? Okay.